So now we are fully equipped with
The idea of what 8085 can do externally is told. The internal architecture, that is the register set of 8085, is also told. So everything is known fully. Therefore, we are now in a perfect position to understand the entire instruction set of 8085. I have got a particular sequence in mind through which we will proceed, and the students who are, if say, I don't know whether such students are there, somewhat curious about knowing the instruction set of 8085 in detail. In that case, what they should do, is that they should go through the instructions which I discussed in the class and should refrain from going through the instructions which are not discussed, because there may be some confusion. If they go through some book and they find that they are able to understand, it's fine, but even if they are unable to understand, it doesn't matter much. So let us focus completely on what I say here. I am sure that most of you must not have noted down, but you can watch it any time. You can watch it at a enhanced speed so as to recap. So instruction set, we must keep in mind the internal architecture. What are the registers? Flag register we shall come later, but prior to that we shall finish almost everything else. Accumulator A, flag we kept aside, B, C, D, E, H, L, then some gap we provide, then we say it to be program counter H, program counter L, then we say stack pointer H and stack pointer L, W and Z, and an instruction register. Is it clear? So, different types, what we discussed, what are different types of instructions? Data transfer, data processing, control transfer, right? So we are focusing right now data transfer instructions. So data transfer. We discussed 3 instructions in last lecture. What those are? Load accumulator from, store accumulator at, and what was the third? What was the third instruction? Move immediately to accumulator. Move immediately to accumulator, right? MVIA. So those are LDA. It is how many byte instruction? 3 byte. How many machine size does it take? 3 plus 1, 4. Same is with STE. And what about MVIA? How many byte instruction? 2 byte. And it takes only 2 machine cycles. So we shall now go through different instructions. Rather than me explaining what it does, I would like that you should be able to explain what it is. So first and foremost and very simple and obvious is there are 1, 2, 3, 4, 5, 6, 7. 7 registers are there. There are 7 registers. So there should be some way of transferring content from one to other. So there are how many such instructions? There has to be how many such instructions? From each one to other. 6 plus 5 plus 4 plus that it is how much? 7 registers are there. So from one you should be able to transfer into any other and vice versa. So how many are there such instructions? किती येतील? 42. I will give example. The concept is move. Now we focus on simple most data transfer instruction, register to register movement. move, there is destination register, there is source register. Move RD comma RS. Move RD comma RS. How many combinations RD can have? 7 combinations. How many combinations RS can have? 7 combinations. So total instructions are 49. 7 to 7, of which 7 are redundant. Are you getting me? लक्षात आहे का बघा? RD there can be 7 combinations. RS there can be 7 combinations. So the instructions are 49, of which 7 are redundant. But while designing the instruction set, if you go through instruction set, these instructions are there. Means suppose if I want to copy something, I write whatever is here on other page. I copy. इथं जे तिकडे देतो. असं होऊ शकतं ना, इथं काही गिरवलं जाईल. लक्षात आहे का बघा? Are you getting me? There is some data on one page. म्हणजे तुम्ही हे करता, काय करता? जर्नल कॉपी करता. म्हणजे काय करता? दुसऱ्याच्या पेजवर जे आहे ते आपल्या याच्यावर लिहायचं. समजा असं अगदी ते मेकॅनिकली काम चालतात, डोकं लागतच नाही, लावत नाही आपण, आणि अगदी झोपेच्या स्टेजला आहे, तर काय एखादा काय चूक असं कुणी केलंय काय, त्याचंच जर्नल घ्यायचं आणि त्याच्यावर लिहायचं. कॉपी देअर इट सेल्फ. गिरवलं जाईल ना अक्षर, आपण सेम असं लक्षात धरूया. सो इट इज डिझाईन मुद्दाम केलेलं नाही हे. इट इज डिझाईन कन्स्ट्रेंट दॅट देर आर सम same to same instructions. So the logic is simple. Actually, there are different such instructions, and the instruction format is also simple. The format is 0. There is only opcode is needed, and in that opcode, the opcode is also further minutely divided. 0, 1, and these 3 bits are for RD, and these 3 bits are for RS. So I think the convention uses R is small most of the times. So we use that. So this is RD. So these are 3 bits. These are 3 bits. So 3 bits can have how many combinations? 3 bits can have how many combinations? 8 combinations. 3 bits can have 8 combinations. What those are? 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. Now there is some simple logic that 0, 0, 0 is B, C, D, E, H, L, and somehow, why there is no specific logic, this accumulator is A, is 1, 1, 1, and 1, 1, 0 is unused. We shall come to it later. Is it clear? So if 1, 1, 0 is also to be used, how many instructions will be there? 64. 3 bit 8 combinations. 3 bit 8 combinations. 8 into 8, 64. Right? Right now 1, 1, 1, 1, 1, 0 is not used. So 49 combinations. So what will be this instruction? 0, 1, 0, 0, 0, 0, 0, 1. This would be opcode is 41. Opcode is 41. Then next I will tell you. This is So different combinations we get. Based on these different combinations, we get various instructions. So what will be this instruction? Can you tell? If you are able to tell, I can understand that you are with me in understanding the contents. What it would be? That would be? Is it clear? I think there is no rocket science. So all these instructions are there. There are 49, of which 42 are valid, 7 are dummy. Means it's not that I changed the word. 42 are meaningful, 7 are dummy, right? Is it okay? So we get 49 such instructions. Then I will write a sequence and you tell me how it will work. At 0, 0, 0, 0, there is 3E at 0, 0, 0, 1, there is 55. At 0, 0, 0, 2, I want to have move B comma A. B means 0, 0, 0, 0, 0, 0. This is 1, 1, 1. This is opcode for LDA. This is opcode for move B comma A. Now you tell me how the thing will proceed further. Type after reset how the thing will start. Address data. After reset, I think it is repetition. It is which cycle? First is opcode fetch address. Now we make one convention. We don't try program counter giving because in 90% cases program counter gives. If some other register is giving, then we mention that. Otherwise we assume that whatever comes on address lines is coming from program counter so that some space is saved. What is the data?
3E.
And where it will go?
Instruction register.
Then read cycle 0, 0, 0, 1, 55. Where it will go? It's repetition. MVIA. Where it will go? Accumulate. This, when it has read the instruction MVIA, it comes to know it is 2 byte instruction. Next byte is there to go to accumulator. So this 55 will go to accumulator. The instruction is read completely and it is also executed. Right? The next. When the execution is over, fetch will start. 0, 0, 0, 2, 47. Where it will go? 47? 47 where it will go? What is 47? It is opcode fetch. So where it should go? Instruction register. Now you tell me what should happen next. Take some time and somebody should tell. Move B comma A is 1 byte instruction. It is what kind of instruction? Data transfer. Where is the source? Where it is? Inside or outside?
Inside.
Inside. Where is the destination?
Inside.
Inside. So whether for execution of the instruction itself any more cycle is needed, whether something is to be brought from outside, no. Then what will happen? What should be next cycle? समजा आता आपण असा एखादा अवघड विषय आहे, सगळ्यांनी इथं बघायचंय. हॅलो, एक अवघड विषय आहे. आता वर्गात काहीतरी लेक्चरला सांगितलं, मग वर्गात लेक्चर सांगितल्यानंतर ते काय करता पुन्हा वेगळा अभ्यास करायला लागतो. मग वेगळा अभ्यास करायला लागेल. किंवा तुम्ही वाचता एखादी गोष्ट, अवघड गोष्ट आहे, ती वाचली, ती वाचल्यानंतर तुम्ही काय करणार? पुढचं वाचायला घेणार का काय करणार? इफ assuming that you are undergoing meaningful learning process, if you are undergoing a meaningful learning process, you will read one sentence, one page. What is the entity? One page you may read. If that is difficult, then will you go to read the next page immediately? Then
Read again.
you will work on the what you read in the rough book or something like that, and then you will go for reading next page. But if the page which is there contains a simple, so that you have understood them while reading itself, what will you do? Go to next page. So the instruction move B comma A is of simplest type. Why it is of simplest type? Because both source as well as destination are inside the processor. So it gets, म्हणजे अगदी सोपा आहे तर मला अगदी सोपा असेल तर मला कधी लक्षात येतं? वाचल्या बरोबर लक्षात येतं. म्हणजे वाच ह्याच्यासारखं सोपं उदाहरण तुम्हाला कुठेही मिळणार नाही. वाचल्यानंतर ते काय करता थोडा वेळ लागतो जर ते अवघड असेल तर. मग त्याकरता पहिलं वाक्य वाचतो, काय करता मी थांबतो, मग दुसरं वाक्य वाचायला घेतो. आणि ते अगदी सोपं असेल, दॅट यू आर मोस्ट इंटेलिजंट पर्सन इन द वर्ल्ड असं वाक्य आहे, तर ते काय एकदम सोपं आहे. वाचल्या क्षणी ते कळतं आपल्याला. आणि मग आपण काय करणार? नेक्स्ट. सो व्हॉट विल हॅपन नाउ? व्हॉट विल नेक्स्ट सायकल? ऑफ कोर्स फेच फ्रॉम नेक्स्ट. काय माहित नाही तिथे घेऊया आपण. अँड व्हॉट एव्हर इज देअर विल गो टू IR. पण आता एक प्रश्न विचारा तुम्ही, मग याचं एक्झिक्युशनचं काय? MVIA, how it was executed? MVIA was how many byte instruction? 2 byte. Destination accumulator inside the processor. Source outside the processor नक्की आहे, पण आपण तसं म्हणत नाही की आउटसाइड द प्रोसेसर आहे, पण तो एका स्पेसिफिक पद्धतीने आहे. काय म्हणता येईल त्या बाबतीमध्ये? मगाशी तुम्ही LDA शिकला इन लास्ट लेक्चर. LDA 5000. व्हॉट इज डेस्टिनेशन accumulator? व्हॉट इज सोर्स? एक्सटर्नल लोकेशन whose address is given in the instruction. आणि MVIA destination accumulator inside the processor. and source आपण आउटसाइड आहे, पण आउटसाइड पण म्हणत नाही. आपण काय म्हणणार? सोर्स. where is the source? Source is in the instruction itself, so it is called as immediate addressing mode for source. Destination register addressing mode, source immediate addressing mode. So when I read MVIA, I come to know that next byte is the data to be put into accumulator. So whenever that 55 comes, that goes to accumulator. Execution is complete here itself, because the operand was that way outside. operator outside, it was read as a part of instruction using program counter only, and the data was available outside, was brought by in the cycle, and that goes to accumulator instructions over. Now here what will happen? Move B comma A, 47 goes to IR. There it understands what is to be done. A to be transferred to B. So when it will take place? Immediately, internally. It doesn't require any bus. It doesn't require any bus. The moment at which it understands that it is move B comma A, what it does? So we write here in the bracket. Why in the bracket? Why in the bracket? Can you answer? Why it is in the bracket? It is not appearing on bus. It is not appearing on external data bus. Data bus of microbus. It is happening internally. Is it right? So like that, there are 42 meaningful and 7 dummy move instructions that can take place. Right? Like that, we are having instructions MVI, move immediate, A, B, C, D, E, H and L. So all are immediate addressing mode, moving to a specific register. So each is having different codes. Each is having different codes. MVI, what is the code? 3E. Like that, there are different codes. So MVI H26, MVI L2E. These are different codes. So each of them is how many byte instruction? What are you doing? Hello. Look here. Each of them is having 2 byte instruction. First byte opcode, next byte data, which is expected to go to one of the registers. How many such instructions are there? 7. There are 7. Is it right? Okay. Now, sometimes, again, those days, saving the number of bytes was something considered to be a good design. Also, space was there in the instruction set design. So, most of the times, I need to use BC pair, D pair, HL pair. So, suppose if I want that B should be 20 and C should be 00. So, I can do MVI B 20, MVI C 00. That I can do, but just it doesn't achieve much purpose. 1 byte is reduced. So, there are some instructions called as load register pair, LXI. Then why L? For move immediate MVI is right. Then LXI, somehow they gave the mnemonics. म्हणजे आपण आता WhatsApp मध्ये ग्रामर जो काही सुरुवातीला केला असेल त्याच्या डोक्यात तो तसं करतो. So like that the assembly language designer has done it. Load register pair. कितने register pair है? LXI B. पेयर म्हणजे B पण C लिहित नाही, BC. LXI D, LXI H. आणखी एक रजिस्टर पेयर आहे की जे आपण नंतर वापरू. That is SP, program counter. Sorry, stack pointer. LXI SP. So there are 4 LXI instructions. There are 4 LXI instructions, right? किती बाईटची instruction असणार? 3 byte. This is 3 byte. So I will take one example, and or before that I had said that in my move template one combination 110 was unused. In my move template one combination was unused. There are how many registers? 7 registers. There are how many 3-bit combinations? 8. So there was one combination unused. So I used this combination like this. This is a very interesting instruction. That is move so I will tell you what is the meaning requirement of this instruction. Suppose if that sometimes you want to you must have in first year, you must have written block transfer programs using some kind of higher level language. Data from copy, आपल्याला आपण त्याला मास्टर कॉपी करणे, जर्नल कॉपी म्हणून आपल्याला सगळा अनुभव आहे. ब्लॉक ट्रान्सफर म्हणजे काय असतं? पहिली ओळ घ्यायची, लिहायची, दुसरी ओळ घ्यायची, लिहायची. So now I will tell you, write a program to transfer block of 8 bytes from 8000 onwards to 9000 onwards. कसा प्रोग्राम लिहू आपण? Write a program, लक्षात आलं? Write a program to transfer block of 8 bytes of data from 8000 onwards to 9000 onwards. म्हणजे 8000 onwards ला 8000, 8001 up to 8007 काय डेटा असेल तो 9000 च्या ठिकाणी लिहायचा आहे. कसा लिहायला लागेल? थिंक फॉर अ व्हाईल. काय करायला लागेल? What should be the way? Write a program to transfer 8 bytes of data in the memory from address 8000 to 9000. काय करायला लागेल? What is the program? Using the instruction which you have studied till now. Using the instructions which you have studied till now. तसं काय लिहिणार? प्रश्न लक्षात आला? उत्तर आलंच पाहिजे. आणि याचं उत्तर येत नसेल, आता ऍक्च्युली आपलं शेवटी लेक्चर पाहिजे होतं, म्हणजे उत्तर आलं तर बाहेर नाही तर इथं वर्गात. तसं नाही आहे. मराठीत सांगतो 8000 ला मेमरी एक्सटर्नल आहे की नाही, तिथं काहीतरी डेटा आहे. 8000 ला 8001 ला 8002 ला आहे. तिथं जो आहे 8000 ते 8007 पर्यंतचा आहे तो 9000 to 9007 पर्यंत न्यायचा आहे. कसा नेणार? LD? Anybody else? How many of you have finished? अरे येतोय का नाही? Everybody should write the program. I want to see.